Okay, in this video we are going to review everything in the circles chapter. So I will upload this circles graphic organizer for everyone. So let's first start with some vocabulary. So we have a circle, and you can see this dot right here. That, of course, is the center of the circle. This is a line going through the circle, so we call that a secant. This is going from the center to the side of the circle, so this is the radius. This arrow is pointing to this whole line, so this is going to be the diameter. Now, this one is not going all the way through, so we are going to consider this right here a chord. And now this is a arrow here, and then this has an arrow. So this one's going to the line, so we're going to call this the tangent line. So that means, what is this? Well, this is the point of tangency. Now, something special happens at the point of tangency, and we learned that in 10.1. And what happens there is if the center is connected to the point of tangency, it's going to be a right angle. So, moving on and looking at a couple of other little things here. More definitions. Okay, so we have a central angle. So what is a central angle? That is where the vertex is going to be at the center. So right here would be a central angle. A minor arc in this picture right here would be CB, okay? And a major arc, you can see it labeled, is all the way around. So a minor arc is less than 180, and a major arc is greater than 180. So the semicircle we know is 180 degrees, and you can name it with 3 letters, okay, if it has the letters there. Now, a very important concept for you to know is that all circles are similar. So I have 3 different circles here. Circle 1 is similar to circle 2, and circle 1 and 2 is similar to circle 3. It is because the radii, no matter what the radii of those circles, so if this was 3 and this was 5, that's a 3 to 5. Okay, so the radii is going to make them proportional. Now, the standard equation of the circle was the last thing that we looked at. It is center, HK. A point on the circle would be XY. R would be the radius. It's very important that you know this formula. The x minus h squared added to y minus k squared equal to radius squared. Now remember, the radius is always squared when it goes into the equation, but when you take it out of the equation, you square root it. Now, we have learned a lot of things about circles, okay, in this chapter. So for chords and arcs and circles, we've had lots of theorems, and it was a challenge to get all of the theorems on this one piece of paper. So the first thing is congruent arcs and congruent chords. This was theorem 10.3. It states, if AB is congruent to CD, then the chords are also congruent. It's a biconditional. If the chords are congruent, the arcs are congruent. Perpendicular bisectors. Okay, now this is 2 theorems. This is going to be 10.4 and 10.5. This one states if QS is a perpendicular bisector of TR, then QS is a diameter. So you're going to look for perpendicular bisector, that's a diameter. The other one, if this is a diameter and that's perpendicular, then those will be bisected. Now, the next one we looked at was theorem 10.6. Congruent chords are equidistant. So if chord AB is congruent to chord CD, then these measures are the same. Notice it's always going to be the perpendicular distance. Now, going to the bottom here, we learned about the arc addition postulate. That was postulate 23 for us. And it's basically saying one big arc, arc ABC, is equal to the 2 smaller arcs that's adjacent. So AB plus BC. Theorem 10.8 was the inscribed angles. So if these angles here intercept arc AB, therefore those angles are congruent. Theorem 10.9 if this is a 90-degree angle, okay, then AC will be a diameter. Notice that biconditional, if and only if. If that is a diameter, then that angle must be a right angle. Theorem 1010 was the quadrilateral theorem. It says that a quadrilateral can be inscribed inside the circle if and only if angle D and F, they're not going to necessarily be congruent, but they're going to be supplementary when you add them. Same thing with E and G. So it's the angles opposite must be supplementary. Now moving to the back of this, I had to work extra hard on this because we have now learned, okay, about angles and segment lengths inside of circles. So the first most important thing I need you to know, this is talking about angles. Now in the previous module I actually showed you this and I gave you a copy of this in the module. It's all about where that vertex is at, okay? So if the vertex is at the center, okay, it's a central angle. So whatever the angle is, the arc will be. Now, if it's an inscribed angle, so here is an inscribed angle, and angle 1 and angle 2 is considered inscribed, you are going to take half to find the angle inside. So this is theorem 10.7, this is theorem 10.11. So just for example, if this AB was 100, ADB would be 50 degrees. Now, if the vertex is inside the circle, in theorem 10.12, we learned that we add the arcs that are opposite, we add them and take half. So I told you to average them. So DC and AB are opposite. They're vertical angles here. So you look across. To find angle 2, you go this way. So you add the arcs and then take half. Now outside the circle, this was theorem 10.13, and it had 3 cases. It can be a secant and a tangent, 2 tangents, or 2 secants. But it really doesn't matter. What you need to do is you do the big arc, subtract the little arc, take half. And you do that for every picture. So the big arc, subtract the little part, and then you take half to find that. Now the very last thing we did in the chapter, we actually did segment measures. Okay, so segment measures. Now back with 10.2, we learned tangent. If SR and ST are tangent segments, then these are congruent. So that's what the tangent tells me about segments. Now, chord, okay, this is 10.14. This is when the chords intersect inside and it makes proportional triangles. So if you'll remember, we proved those with making similar triangles. But how you remember chord is part times part equals part times part. Okay? Now, secant was 10.15. Okay, so these are secants. But for this one, EA is a part, while EB is a whole. EC is a part, and ED is a whole. And remember why that's happening? We made 2 triangles again, and it's just proportions. So part, whole, and the tangent secant, which is 10.16, okay, it basically acts like this one. It's this part and that whole, because it's the same thing, so it's that squared equals that part times that whole. So everything in chapter 10 is on this one document.